So, good morning, good afternoon, good evening, participants from all over the world. Today, we are going to have a high level overview on Snowflake. And the speaker of the day is Theresal. He's a tech evangelist and specialized data engineer at top Fortune 500. Yeah. Moving to who we are, what we are. We are fifth IR, which stands for Fifth Industrial Revolution. We have over hundreds and thousands of strong community of technologists from all over the world. We deal with technical sessions, consultation, and project on multi-cloud strategy, data science and AI, blockchain, and stream engineering. We also help technologists to share their learning and get opportunities through our partners worldwide. This is a short infographic how we are growing. We have offered 1,000 plus sessions through our platform. We have 300 plus PKs associated with our platform, and we have offered 8,000 plus certificates through our platform. These are the few master mentees and MEPs associated with our platform. We are an academic partner of Alibaba Cloud, and these are the few certification programs and courses which we have done in line with Alibaba Cloud. How we can help you? We can help you to build your knowledge, digital presence, and help you in other ways when you are looking for jobs through our community. All you can access through our link www.fifthir.com. Fifth IR stands for Transit Towards Fifth Industrial Revolution. As a part of our community, we are going to provide a free level 1 certificate for all the participants, and you can access the certificate by providing the secret code, and the secret code for downloading the certificate will be shared to you in your mail ID. So this is a sample certificate which you can get, and you can share that in the social media platforms. So moving to the speaker of the day, it is Theresal. She is working as a specialized data engineer at top Fortune 500. She has been associated with different roles in the organization, such as specialized data engineer, senior software developer. She has got a couple of certifications from AWS. She's an AWS certified data analytics, and she's a data engineer on Microsoft Azure, and she is a certified Snowflake Pro engineer. So you can see more about her in the given LinkedIn profile. So now, without any ado, I am passing the control over Theresal.
Yeah, thank you, Gavaskar. Thank you for the introductions. Let me start. Yeah, hope my screen is visible. Yeah.
It is visible. You can make it full screen.
Yeah, 1 second.
Hey.
Is it okay? Slide share. Gavaskar, is it okay? Slideshow?
Yes, you can proceed.
Okay. So good morning to all once again. So today we are going to see about the Snowflake in high level overview. What is Snowflake? Everybody thinking what is Snowflake? It's how it is very important nowadays, right? So what we have done previously. So before coming to Snowflake, what we have done previously. So Snowflake we are using for the data storage, processing, and analytic solutions, and in the fastest manner, and it's a good performance also. So what is lagging in the traditional things which is competitor for the Snowflake? So Snowflake mostly we are using for the data warehouse as a service. What is data warehouse? It's nothing. So every day we are doing some transaction, right? So yeah, we are splitting the operation as two things, OLTP and OLAP, right? So OLTP is a transaction and OLAP is an analytic process. And OLTP, everyday transaction, we have to keep it in the OLTP. So you can ask me the questions whether we can use the Snowflake for the OLTP. No, not at all, because it is a warehouse device. Only we are using for the OLAP purpose. What is OLAP? It's an analytic purpose. So that means the data warehousing. So every day we are doing some transaction that we have to keep it in one data warehouse for the analyzing purpose. Okay. So every day you are doing some transaction. Finally, the bank want to do the analysis on what you are doing, right? So what you are interested, what you are buying interested in the Amazon, like those things we are analyzing from the data which is provided in the data warehouse. Okay, so previously what we have used means just before to Snowflake, mostly we will know the Hive, right? So Hive is a data warehouse tool for the big data. It's a booming one nowadays. Also we are using, uh, but there is a problem in the Hive also. So what is the problem? We are facing the scalability problem, monitoring problem, and implementing multi-tenancy problem also we are facing in the Hive. So those all and all taking care in the Snowflake. Okay, so Snowflake, we are saying it's a innovative architecture. It is taking the architecture from the existing traditional data warehouse. What is the existing traditional data warehouse? It is nothing. It's a shared nothing database architecture and shared disk database architecture. What is shared disk? In the sense, suppose you are just thinking that is one storage. Okay, so normal database you just think, so we can share anybody can use that data from the storage. That is means shared disk. What is shared nothing? For example, the Snowflake, we are having lot of compute node. So in the compute node, so we are taking data from the storage. Okay, we are taking data from the storage and keep it in this cluster itself, or the compute node itself, and doing the processing. That means one compute node will not take the data from the other one, and we are not having the contact with the other data, other compute nodes. That means shared nothing. So what is the benefit of shared nothing? We can do the query processing in the well format manner. So that is why it's a main booming in the market. Why? Because of this architecture, because it's having the shared disk and share nothing architecture. And next things, the data repository. It's like how we are persisting our data in the data repository. So here the Snowflake, let me see that architecture in the later. So there is a storage layer. We are keeping all the data inside, and it is the storage layer act as a shared disk architecture, and the compute layer act as a shared nothing architecture. And lastly, it is so some people, they know, right, what is Snowflake. In the sense, the first thing they know about, it's a software as a service. What is software as a service? So we are not taking care of any hardware and software related things. Only we are doing the data. So what is the insight we want to take it from the data? That is only what we are doing in Snowflake. But in the traditional data warehouse, we have to do some monitoring, we have to do some operational work behind the database or behind the Hive. We have to do the scalability process, everything we have to do it. So these all, the Snowflake eliminate all the remaining work. Only we have to do what is we needed from the data. So that is why, so everybody migrating from the other traditional data warehouse to Snowflake. That is a very important thing in Snowflake and advantage. So obviously we have seen the same advantage earlier. So we can scale up and down easily, and better speed and performance also we will get. That is why the shared nothing architecture, we are getting the high speed and performance, and it is combined structured and semi-structured data. So without any additional transformation, we can convert semi-structured data also in the Snowflake. That is very important thing. And multi-cluster architecture we are facing. That is why we are getting the concurrency and accessibility for anywhere in the world. Concurrency in the sense, we can run more than one query at the same times, but one query will send to one compute node. So we can scale up, if we need the concurrency, we can scale up the compute node, or we can use the multi-cluster compute node also. And the next one, shared data. So that is what the shared disk architecture, we have it in the storage area. And this the next very important thing is, it is the cloud agnostic in the sense, it does not depend on any one cloud. It use all the cloud, like whatever in the market. So we have in the market AWS, Azure, GCP, and others also. It is using all the cloud. And the last one, it is high availability, and we can obviously, if you are going with the cloud, obviously there will be multiple region we can store the data, multiple available zone we can store the data, right? So because of that, we will get the high availability. The last but not the least, the pay as you go service. Why it is a pay as you go service? Whenever we want, we are going to use the storage, or for the computing purpose, if you are using computing node, only for that we need to pay it. Okay, now lot of serverless services we have it in the Snowflake. It makes us very comfortable as in the pay as you go service. And this is the architecture. This is the traditional architecture, and this is the Snowflake architecture. By seeing itself, you can understand what is traditional architecture. First one is the shared disk architecture, so that the storage, the data is shared by um, any computing node, right? So here only shared nothing architecture, only the computer node, whatever it is using the data, it's separated. That means total data locality we are getting from the data nothing data warehouse. And Snowflake comprise these two things, and it's providing the better performance. And this is the three layer we are using for the architecture. First one is the cloud service layer, and query processing layer, and database storage. So let me see one by one. So first one is cloud service layer. So what is this? This is the brain of the Snowflake architecture. So here we have the collection of independent services designed specifically for scalability and high availability. Okay, each one will be independent to each other. So lot of management services we have, like authentication, infrastructure management, and metadata management is one of the main thing we need to take care of, this metadata management. And query parsing and optimization we have it, and access control also we have it. So let me see one by one later. Maybe in the meanwhile, the other topic I will add these also. And the next one, um, processing layer. This is the compute layer. This is the muzzle of the system. We can say this is the muzzle, and the service is the brain of the system. And what is this processing layer? So actually, I said this is the compute layer in the earlier things. So the compute layer, we have the virtual warehouse. Okay, so the virtual warehouse, it's nothing but your compute node. So we have a massive parallel processing compute cluster to execute the queries. Okay, so here we can have the um, cluster also, the maximum. We can choose this while you are choosing the virtual warehouse. We can choose which kind of virtual warehouse, size of the virtual warehouse we can make it, and what is the maximum cluster, minimum cluster, everything we can specify in the virtual warehouse. Suppose if your query have complex query, right? Complex query, so virtual warehouse we have in the T size, okay, XSS from then 6XL we have it. So it depends on the size of the RAM and the disk size we are using. So suppose if you are using the small XS for warehouse, suppose the query, it's a complex query taking more time. So what you will do, we can scale up it. So it's very convenient thing in your Snowflake. So we can scale up and scale down the virtual warehouse. But obviously, when you are going for the high size of the warehouse, the cost will also increase. But whenever you need that query need to be compute fastly, then we can go with the scale up and scale down process also. It's possible in Snowflake. And as per the demand, that is what the cluster can be scaled to demand, essentially accessing the same underlying data. And let me see one by one later. Database storage layer. So storage layer, as I said earlier, this is the shared disk architecture. So any compute node can take a data from it, and they can do the query operation on it. Okay, and whenever the data storage layer is a very important thing in the Snowflake, we are seeing lot of features in the Snowflake, right? So a lot of features, like one of the main feature, few of the main feature I will tell you. So time travel, cloning, and zero copy cloning. So those things are fail safe and all. How we are attaining that from the Snowflake because of the storage layer, how it is storing the data. According to that only we are facing these all features. Okay, so for example, if you have the data, okay, so normally the data loading and unloading we are doing by the stage. Okay, so we will see that later. So if you are passing the data from your local or from your stage to Snowflake, what it will do, it will store like normally in the database we will store like a static partitioning, right? Partitioning in the sense how fast we can query the data, that is depends on the query tuning we are using the partitioning. The same thing here we are using, instead of static partitioning we are using the micro partitioning. So what is this micro partitioning? Suppose if you have a table, so if you have a like it's a normally if you are saying table, it's a row wise. If suppose if it is a 10 tables, 10 rows, so how it will store as a micro partitioning? Micro partitioning is nothing. It's a contiguous unit of storage. That's all. Each unit have 50 to 500 microbyte uncompressed data. So depends on that size, the table will be converted into micro partition. And micro partition, it's a immutable one. Okay, that is very important. It's a immutable one. The table will be vertically like horizontally scalable, but the micro partitioning is vertically scalable. Okay, that is very important because it is immutable. Suppose if you are doing some DML operation on the table, how it will transfer to the micro partitioning means it won't delete. Suppose if you are doing some update, if you are doing some delete operation, it won't go and do the delete operation and update operation on the existing micro partitioning. It will create the new micro partitioning and it will do the process. That is why we can attain the time travel and cloning and all we can do by the Snowflake. So maybe I will show you in the next slide. Okay, this is the micro partitioning. So this is your table. Okay, you have the 11 rows. Okay, these 11 rows is converted into 4 partition, maybe 4 for each other, right? So I sorry, 3 3 each other, because it's 4 3 3 each other, 3 rows per micro partitioning. So the micro partitioning is from the row wise, but inside the micro partition it is a column level storage. Why we have to go for the column level storage? Because the query fetching will be fast when you are using the column oriented level storage, right? So here, and one another thing is also there. So after the micro partitioning, so we have the clustering concept also inside the storage. So what is this clustering? It automatically it's doing, we are not doing any part in this micro partitioning, this much partitioning we have to do that and all. We are not telling to the Snowflake itself, it's doing all this work because of us. So what it will do, the cluster. So for example, this is the same example I am taking. So here I have used the clustering as employee ID. Okay, the previously I have chosen the employee ID as a clustering column. Okay, so that time what it does, because employee ID is the unique, as we know that it's a high cardinality, so it will take employee 1 2 3 subsequently it is taking. But I need to fetch the query like the same table in terms of department ID is equal to 1. So what it will do, it will take all the department ID from micropartition 1 2 and 4, right? So it's maximum, it's running around all the micro partitioning and it's fetching the data for your result. So what you can do instead of that, so that time I want to change that employee ID as a not employee ID, so department ID as a clustering key. So that it is possible in the Snowflake? Yes, we can possible. We can do by default clustering principle inside the Snowflake, as well as we can do explicitly by querying operations. But it will be the cost effective, because every time when you are changing the clustering key, we have to pay for it because it's altering all the micro partitioning inside the storage, right? So we have to pay for it. So for example, if I am partitioning by the department id or clustering by the department id, so now what will happen if I am fetching that department id is equal to 1, only it will fetch or pruning the micro partition 1 and you will fetch the data, right? It is very faster than the previous one because previous one it have gone for 3 micro partition and fetching the data. So here the one single partition you can fetch the data. So the thing is how much fast you can fetch the data. And again, while you are fetching the data, everything will be stored in the metadata of its micro partition. It is having all the micro partitions and what is the statistics about each partition, everything. It's over how many overlap it's there, because the same department id will be there. And suppose if it is excess in the micro partition one, obviously it will be stored in the next one, right? That is we are calling as a overlapping. So we have so many the parameter we have to check it in the clustering, so that you just study later. So this is the overall view how the data is stored in the storage layer. So this is why we are getting the time travel, because as I said, the micro partitioning is immutable, right? So because of this immutability, you are getting that time travel, because whenever I want to fetch the query at the past times, we can take it. So cloning also it's possible. Cloning also one of the main feature in the Snowflake. So while you are cloning, what it will do, it will take all the data. Suppose if I am cloning the same table, it's take this say a same table, and but it won't create the another one physical micro partition. Take the same partition logically. And suppose if you are doing any changes on that cloning table, that will create a separate partition, micro partition for the changes in the particular table after cloning. So that is why the cloning is, we are saying it's a zero copy. Okay, so why we have to choose for the Snowflake? Obviously now you have a thorough idea about Snowflake, why we have to go for the Snowflake, right? Obviously it is a very high security and governance about the data, and data protection also it's very high in Snowflake. I will tell you later while we are seeing about the tables. And it's support the basic native SQL support only. The connectivity is SQL support connectivity, and all other connectors we can use like a Python, JDBC, ODBC, Java connector. We can use all kind of connectors. And the choice of data you can choose structured and semi-structured data also it is possible. And continuous bulk loading data from the files, it's possible in Snowflake. And management is hand free, totally it's hand free. So as I am saying, this micro partitioning and clustering, all this cloning process and all, it's doing behind of us, right? Because we are not doing anything, the Snowflake itself doing all those things, and pay as you go. So once if you use that service, we have to pay for it. So a lot of serverless concept is there in the Snowflake, that makes us in vigilance about the cost also. And performance and speed is very high. And cloud agnostic, we can use any kind of any one of the cloud we have in the market. And CDC change data capture also it's possible, that we are going to see in the demo. And result catching, so what is result catching? It's very important thing. So we have the metadata, right? In the metadata it's storing all this result catching, like we have lot of catching things is there: metadata catching, result catching, warehouse catching. So suppose you are using one query, select star from this table, right? So the same query if you are using again, first it will go and check the metadata, whether the same query existing in the last 1 hour not. If it is if it, not 1 hour, 1 day, so 24 hours. So if it has happened, it will fetch the data directly from the metadata. It won't go and do it in the compute node again. It won't fetch the data directly. We are taking from the metadata and we are doing. That's why first time it takes 1 minute, means second time obviously it takes seconds of times. So that is why, because of this result catching, we have a lot of catching methodology in the Snowflake that you see later. um, and these are the object we are seeing in the Snowflake. Okay, account, it's a main thing. So the below the account only we have all these user roles. And virtual warehouse, which virtual warehouse we have to choose is, that is in your hand. Suppose if it is a serverless, then the so Snowflake will take care of that virtual warehouse, how much what kind of compute node virtual warehouse we have to use it and all, they will take care. And resource monitor, it's a very important thing, because we people mostly forget about that how many compute node it's running, right? So it helps to control the cost, because according to the usage only we have to uh, pay it, right? Because it's a pay as you use. So helps to control the cost, unexpected credit usage, that and all, it is monitored by the resource monitor. So the number of credit consumed depends on the size of the warehouse we are using and how long we are using the same data warehouse. So resource monitor will alert the notification, will trigger the various actions, like we are getting the notification like notify, suspend, notify and suspend immediately. So those kind of trigger we have it in the resource monitor. We have to set it first itself. Suppose if 50 percentage of the data warehouse is used, we can keep it for individual warehouse or individual user role or individual account. We can use the resource monitor. Suppose we can say to the resource monitor, okay, this much percentage I used to just give me notification, this much percentage I used to give me the suspend, this much the 95 percentage of my credit is used means please terminate it. So like that we are telling to the resource monitor to save our cost, right? Because the billing and all we have to be take care with the help of the resource monitor. And integration, so why we have to use the integration? Like suppose if you have a data in the S3 bucket, okay, so you are taking through the external stage, so that time integration should be work. And database, obviously we know that it's a main collection, right? Collection of your schema is a collection of table, view, all those things. It's comprised under the schema is comprised under the database is comprised under the account. And views, obviously views is taken from the table. There is a lot of views we have. Secure view we have nowadays, okay, normal view, secure view, materialized view we have. So each view have the separate usage, that we have to say. The table and all, we have 4 types of table. Next slide we will see that. And stored procedure and user defined functions, that and all, when you are going for the transformation we can use it. Stage, obviously, so for the data loading unloading we are using the stage. And the file format, obviously it is helpful. So when you are loading some data, what kind of file format it is, we can tell it's previously while you are loading to the stage. And pipe, obviously when you are loading your data from the external to Snowflake, we have to use the pipe. And sequence, obviously if you need the sequence of numbers in your table, we can use the sequences. And data warehouse, so as I said, so data warehouse, we can see in the demo also. Before that I will just tell you what is this data warehouse. So we can initiate and halt this data warehouse at any time. That is very important, at any time. So if you want to suspend, we can do it by using the alter warehouse compute. What is the compute warehouse you are using? You can suspend it at any time, you can resume it at any time. So obviously all the time it will be in the suspend state only. So suppose if you are saying show warehouse, you will find it what are the warehouse you are using in the particular account, right? So suppose if you want to resume it, you can use this command, okay? So we can drop any warehouse at any times. And we can alter the warehouse also, because alter the warehouse is a very important thing. So suppose if you manually, if you want to alter it, if you want to change the warehouse size, we can do by this alter command, okay? Auto suspend, auto resume, what is this use? It automatically suspend your warehouse after 1200 seconds, okay? And auto resume, it's automatically, it's we can give the true or false. So whenever you want to make any query, it automatically resume and it will do the query performance. And we can use the minimum cluster size and maximum cluster size. Maximum is 10, minimum is 1. We can choose at anything in your alter statement. And scaling policy, we have this two scaling policy, standard and economy. So maximum, we don't have other because of the enterprise editions we don't have economy. So maybe standard we can use it. Maybe in the company perspective we can use the economy scaling policy command. Whatever you want to make it, you can make it. So this is what all about the data, sorry, virtual warehouse. and database, obviously. So how you have to create the database? Create database as like normal SQL query, and the show database will show all the database what is inside your account, the particular account. And we can create the database also. We can create the database by cloning also possible. Okay, the cloning I already told you. So the cloning, it's zero copying property we have it. So it's cloning from the demo DB. So it's taking all the stages, all the file format, all the tables, all the schemas from the demo DB. Okay, so privileges we have to take care of it. We have to go through the privileges properly, and we have to clone it, and we can drop any time the database. Have you seen this undrop in your data normal database? No, because this is a cutest function we are using in the Snowflake. Undrop. Suppose you by mistake you have dropped the database. Because of its a time travel property, we can undrop that database. Suppose if you have dropped that also, the same thing we can use for the schema, table, anything we can. Once if you drop, we can undrop it because of its a time travel property. Because it's already we said, right, how the time travel is work with the help of the storage. And schema also the same thing. We can create the schema, and we can alter the schema by using the same command like a normal database. And show schemas, it will show all the schemas under that account. And we can clone we can clone also, we can drop also, we can undrop also. And every time while you are opening your workspace, okay, worksheet, so you have to set this all. Otherwise you can do it in the ua also you can do it. And by using the script also we can use it. Use what is the warehouse you are going to use, what are the database you are going to use, what are the schema. These three is very important when you are doing any query operations on your worksheet. And table. So table, normally how will you create the table? Like create table name. So what is this dot? It's nothing. Them. What is your database? What is your schema? What is the table name? Every time we have to go with the same process. That is good, like a way of creating the table. So and then we have to write all the column names and its data types. Data types also we have lot of data types, numbers, varchar, string, integer we have it, and what is the maximum size and all you just learn it. And show tables, you can show the tables. And describe table, it will tell you all what are the columns inside, and other details and all we will get it, whether it is a temporary table or a external table. All those things we will get it from the describe table. And obviously we can clone it, and we can create the another table with using the like command also. We can use by clone command, as well as we can create by the like command. So like command means it will create the physical, again it will create that micro partition for that. But clone, it won't do it. Only if you are changing anything, it will create that micro partition behalf of that. And drop also possible, and drops also possible. And what are the table types we have it in the Snowflake? So normally we have four: permanent, transient, and temporary, and external. Nowadays we have four more other: iceberg table, event table, and hybrid table, dynamic table also we have. You just if you have a time, go and see that all the remaining four tables. This is the basic table what we have it in the Snowflake. So permanent table. Default table is called the permanent. So permanent in the sense the table will be persisted until we delete or drop it from the database. So it's all like how we are choosing this permanent, transient, temporary tables and all depends on your use case, right? Depends on your use case. So what is the use case behind it? So whether we want to persist the data for the longer time, or we want to use the time travel facility, or we want to use the fail safe property or not. Because these are the main features inside the Snowflake that will be given to the each table according to its table, right? If it is a permanent table, we have the time travel facility till 90 days. Even it is the enterprise editions also, the further higher also, we have the 90 days time travel, and as well as 7 days for the fail safe. Okay, suppose by mistake if you drop also, we can go and take the data from the Snowflake. So after 90 days, if you have deleted, you can go with the fail safe that you have to raise a request for the services in the Snowflake, and they will provide you the data which is there in the storage. Okay. So next one is when we have to go for the permanent table. Suppose you need for the data persistence, and if time travel facilities and fail-safe facility, we have to go with the permanent table. So how you can change the data retention period, okay, data retention time in days. Okay, so that is, as I said, it is 90 days. 90 days in the sense, obviously that is a huge cost, right? No, I don't want 90 days, I want only 10 days or 10 or 15 days. Means you can go and change that by using this command. Okay, alter table name, set this data retention time and days equal to how many days you want. If you don't want 90 days, because obviously if it is in a higher days, higher storage cost will be there, right? So that we can reduce by using this command. And how you can see that how many days retention time and days and all, you can go and check it in the show parameter command. You can check what is the data retention time, whether you want to change it or not, you can do it. Next one is transient. So transient is little lower than the permanent, because the persistence again the same. Whenever you want to drop and delete, you can delete. And here there is only data travel till 1 day. There is no fail safe. Okay, so whenever you want to go with the data persistence, but you don't want to go with the time travel fail safe and all, you can use this transient table. So like a staging table and all, mostly we will use in the transient table type. So only you have to use one more keyword in front of this table is transient. So that means it's a transient table. That's all the difference. Okay, other than the time travel and fail safe and persistence. And temporary. What is temporary? It's a name indicate it is a temporary. Only the user they are using only for that particular session, it will be alive. After that, it will be deleted. And can we take time travel? It's 1 day, because in 24 hours you can go and get the data by using the time travel, but the only one user can see this data, other users can't able to see the data from the temporary. And another one question, the temporary table, suppose if I am using the same temporary table in the transient table and permanent table, what will happen? It won't do anything, it will accept it, because it is shielding that permanent table and transient table. Because if you are going to fetch that the same name temporary table what it is having, it will go and fetch the only temporary table, it won't directly go and hide the transient and permanent table. So that is the only security we are providing through the temporary table, which has the same name as a permanent and transient table. Okay, so here also you have to use the temporary keyword in front of the table. And external table. It's entirely different from the all three, because external table you are using for the external storage. Suppose if you have a data in the S3, so we have to create the external stage. From the external stage you have to create the external table. So external table, we are not having any DML operation, we are not having any fail safe, we are not having any time travel. Only we can read only that particular table, we can't able to see any data from the table. That is very important. But the table will be persisted until we are deleting or removing that particular table. Okay, so this is the way you have to create that stage and copy into command, or we can load pipeline, we can fetch the data from the stage to table. So next one is, what are the four types and what is the time travel and its fail safe. As I said, in the permanent table we have the 90 days time travel and 7 days fail safe. And if it is a permanent standard edition and enterprise edition, we have the 90. Standard means even time travel also 1 day, and remaining temporary and transient. Time travel is 1 day, and fails, there is no fails. Okay, and the cloning and all, how we can do the cloning. So external we can't do any cloning, we don't have failsafe, we don't have time travel, and remaining all we can do the cloning. Permanent table you can clone as a transient, temporary, and another one permanent table. And transient table you can't clone as a permanent, temporary table you can't clone as a permanent. So that is a very important thing, you have to check it. And the stages, so why we have to use the stages is nothing. Once if I want to load the data from my local or external to the Snowflake, we have to use the stage. And unloading, again the same thing. So from the Snowflake, I want to take, I want to convert the table into CSV file or something in your local, you can do by using the staging. There is 3 stages. Actually, there is 2 stage, internal and external stage. External stage is only for the S3 bucket, those things and all. Assure, we can use the blob and all. Internal stage, we have again classified into user stage, table stage and name stage. User stages, each user has the Snowflake stage. Okay, so only allocated for the one user. Okay, they can use, they cannot able to alter, they cannot able to drop that stage. The same thing for the table also. Each table they have the table. Okay, so first I will complete this user stage. And user stage, we can use this command to find out what are the particular stage. User stage, we have some files, means you can see that by using list at by tilt command. Okay, so this have the disadvantage, we can't able to alter and drop. One user can't see the other users files and all. This is only the drawback. And table stage also, we can check by the list at percentage employee. Employee is nothing but the table name. Suppose if it is an employee table, the employee table file will be stored in the stage list at percentage employees. So this also we cannot able to alter and drop, and multiple user can't able to load the data for this particular table. Okay, that is a disadvantage in table stage. And that's why it's over, these two disadvantages overcome by the internal name stage. Here both users, we can see any users can see this name stage. Okay, we can create the name stage first by using this command, create or replace stage name, and we can list at the stage name. You can see what are the files inside this stage. Okay, so even for the loading unloading, we can use the same way. And external stage, as I said, we can take a file from S3 to external stage. We can use the list at, we can create it first by using external stage, as I said in the previous slide. And then we can use the list at the stage name of the external stage. You can find it, what are the files inside it. And the next one is the data pipelining and change data capture. This is what we are going to see as a demo. And first, what is change data capture, right? So CDC or data pipeline, data integration, ETL, ELT, all those things, it's a mixing and saying the same thing. Okay, whenever I have a data, I need to move from means multiple sources to the staging table, and from the staging table to the target table. You can say it's a different name of the stage. You can say landing table and staging table, any kind of table you can say. And finally, where you are storing the target table or like a baseline table, you can say anything, right? So that is the ETL process. You are extracting data from any multiple sources, and your loading means EL for loading into staging, and you are doing the transformation. That is we are calling as a extract, load, transform. And previously, mainly the people will do the ETL process, right? First they will extract and then transform, and then they will load it in the baseline table or target table. So that is what we are going to do today also. That is the whole pipelining process. And CDC, let me talk about the CDC. What is CDC? Change data capture. So you are storing, because it is, we are all dealing with the data warehouse, right? Data warehouse in the dense, every day you are every day or every seconds you are inserting some data to the data warehouse. Like you suppose if you are taking one bank transaction, so every day you are updating your if some people want to change the mobile number, they will go and update in the mobile columns, right? Mobile number columns. And update operation, delete operation, somebody it's removing that account, means then we have to drop it, we have to delete it. And some new customers has come, they have to insert it. So every day at the end of the day, the bank will give you the set of data to load in your data warehouse, right? So every day you are facing some insert, delete, update operations on your input data or from the data which is coming from the source. Then what you have to do, you have to find out the change data capture, and then you have to load it in the staging, and then you have to move to the target table. So before moving to the stage, what you will do, so because you have the set of data every day you are getting at the end of the day, or NRT data or near time data you are getting, right? So that you have to move to the stage first. Okay, and then after the stage you have to move some, you have to do some transformation, or you have to move some unwanted things from the filtering and all, you have to do it in the staging, and then you have to move to the target one. So how you will do that? By stream and task in your Snowflake, that we are going to see today. So what is stream? Stream is nothing. It's including all the DML operations, insert, update, delete, all this metadata. One second. Amma meeting ma. So you're doing insert, update, delete, as well as metadata changes also you are doing in the by using streams. Let me see one by one. So here there is a few types of streams we have: standard, append only, insert only. Standard means it will fetch all the DML operation. If it is absent or append only, it will only insert insert operation it will do. And the next insert only operation also it has, it is only for the external table. Okay, external table we can use only insert only streams, that we have to notify in your while you are creating the stream itself. And let me see some samples. First, the table. Okay, this is your staging table. Okay, so the data which is coming from the source, you are inserting data to the table, staging table. After that, you have to create the stream on this staging table. Okay, stream on the staging table. So what it will do, after insert all your data into the table, the stream will create one snapshot, because stream will not have the data storage. It will store only the snapshot, only the offset value for the stream load, stream memory. It will have only the offset data, offset related data. So what it will do, you take the snapshot of the table content at a time, and it will insert, suppose whatever it is insert or update, delete, whatever it is, it take and store it in the further process. Okay, so if it is a standard, we can do all insert, delete, update operation. If it is append or insert, only we can do the insert operation, that we know. And there is 3 extra column we are adding in your stream. So while I am showing the demo, I will show you. After creating stream, okay, so there will be 3 column will be added in your stream. Okay, in your stream, that is your insert, update, delete, whatever the operations you are doing in the every row. And additionally there is 3 column: action, update, row ID. What is this action? The action indicate whether it is a insert operation or delete operation or update operation. If it is update, what it will do, it will tell you whether it is a update or non-update operations. Because sorry, action I said update, right? So there is no update in the action, only insert, delete we have it. So we are not having update or action in the action list. So how we can see that it is a update operation? Because what is update operation will do, first it will delete the previous one and then it will insert the new one, right? The same thing you will get it in the update operation. So if you are doing one update operation, there will be 2 rows is formed in your stream, like a delete and insert. So that we will see later. So and another one, so you have all these streams, right? So every time I can check what is happening in the streams. So by using this select system, stream has data. So what it will do, whether if there is any new data in the particular stream, it will do the remaining process. Unnecessarily, I don't want to do every time the same thing, right? I don't want to fetch the data from the staging table to target table. So when there is a table or there has some data in your stream, then I can do the remaining process. Because only streaming, what it will do, it will collect the DML operations on your table, right? The staging table, whatever the DML operation or CDs you are doing, that will be captured by the stream. But who will do the next process? That is by task. Okay, so first let me see what is the insert, update, delete, how it is happening in the stream. So first one, so I don't have any data. Okay, first I don't have any data. So row ID action is update will be blank. So if I'm inserting some data, so I am inserting one row, what it will happen, it is action is insert, is update is equal to false, because it is not the update operation, just the insert operation. So again, the output you will get, like actually it is update is equal to false. Why? Because actually they are doing the update operation, but initially there is no files in your base table. So what it will consider, it is a new table, and then it will give you the is update is equal to false, even though if it is a update operation, because already existing information, it is previously while you are creating the stream. That why even though it is update operation, you are getting it as a is update is equal to false. And the second one, you are creating the table and you are updating. So obviously is update you are getting it's a true, right? But operation you are getting insert, because we are not deleting any data. So as I said earlier, update we have two operations, delete and insert, right? So here there is no initial, there is no data that time while it's creating the stream. So it will give you only the insert operation. Next one, you have the stream. There is first initially it is no data and you are inserting data. So it's inserted and then you are deleting. So what it will happen? So just after insert it is deleted, right? Because after you are creating stream, what it will do, it won't give you any data, because what is inserted, it is deleted. So now the table is empty. So while it is taking the snapshot, it is empty, so you won't get any data at the three columns. This is how the stream is working. So suppose if you have a empty table, okay, empty first empty table while you are creating the stream, and then you are deleting. So what it will do, so it's only delete operation you will get it. Okay, so insert operation you won't get it, because already there is a table that will be deleted, you will get as a delete operation. So if you want, you can check this later. And this is how it is working. For example, first table, I have the apple and 5 that will be inserted. So that time metadata action will be insert and update is equal to false, and definitely there will be some row ID, unique row ID, you will get it. And next time I'm adding two more. What is that? Orange and banana, and I am updating the apple also. So orange and banana, it's inserted, you are getting the first two command, right? Orange and banana. And what about the apple? If I updated, first it is doing the delete operation, then it is doing the insert operation. What is what I tried to explain in the previous slide, but it won't happen all the time. What are the different cases you will get it, I explained in the previous slide. And the last one, we are deleting. So obviously deleting, it will give you the delete metadata, and metadata is update will be false. And always you will get the unique row ID for every uh, uh, changes in the CDC. And the next one is task. So task is nothing. After you are finding all the CDC in your stream, somebody has to do the some task of after the next level, right? Because I want to capture all the staging CDC, and then I have to move to the target table along with some transformation, or along with additional of some columns, we have to move to the target table. How we can do it? By task. So let me see what is the task. A task is a single SQL statement or multiple SQL statement, or we can call the stored procedure. Anything we can do in the task. So task, there is a two kind of task. One is serverless task and one is user managed. User managed in the sense, user we have to define the virtual warehouse. If it is a Snowflake managed, Snowflake will deal about this warehouse details and all. And the task we have like a parallel task we have it, or like a tree kind of task. So what a is a parent task, right? Root task, and B and C will be the child task. The child task we have a B task have child task D, E, F, and EC have the G and F. So such a way the form of like a tree task we can make it. So how many tasks we can do in the tree is 1,000, and every child task should have, every root task should have the child task is 100. These and all the pro core example they will ask you questions. And suppose if the parent task is disconnected, what will happen? The root task will be act as a parent task, or it will consider there is no precedence task for that particular task. And how to create the task? It's very easy. So create a replace task, and what is the task name? Then schedule 1 minute once. I have to schedule the task. You should not call this task again and again. It will act 1 minute once, and it 1 minute once. How it will do? It will check the system stream has data in the particular stream. The particular stream it has the data. This will be activated. Okay, every 1 minute it will check has data. It has the data or not. If there is a data, then it will call the particular stored procedure, or we can call any kind of SQL statement instead of that stored procedure. This is how it will work in the task. And this is it's very important. Every time the task while you are creating, it will be in the suspended mode. You have to convert that into resume mode, and you can show the task and you can execute task. First initially you have to execute task on account to role, what role you are going to use it. For that role you have to give the privilege from the account admin. That is very important while you are doing the demo, or while you are practicing yourself. This you have to provide it, then only you can do the task operations. And finally you can check by this what you have done in the task. You can check by this history command. Okay, so that's all about today, and let me move for the demo. So okay, so while you're opening your Snowflake, you will get this kind of screen. And I'm using Snow site because nowadays they are providing only Snow site. So web UI, I'm not able to find it. So while you're going with, you have to go with the data and database. You can do all the functions. Okay, and okay. Okay, so here the database, you can create the database. As I said, no, it's we can use by the web UI.
Theresal, your screen is not shared, I think.
Okay, one second.
The GUI part of Snowflake is not shared.
I will share once again. Is it visible?
Yeah, perfect.
Okay. So here you can go and create the new database. What is the name? And if you can give the any command, but I'm not doing that. And such a way I can go create the database, and in the database I can create, how I can hide this. Okay, so in this schema also I can create by the UI. So such a way you can create the schema. I can go with the, okay, I can go with the database. Here I can go the schema. Inside the schema I can go and create any kind of like a object, table, view, and stages. Whatever you have seen in the object in the slides, you can go and see here, and you can create through the UI also. Through the SQL also you can do it. That is what I want to say. Through the UI also you can do the same way. You can do it in the SQL also. Here also you can go and check what are the tables inside the schema, what are the stages inside the schema. And every time while you are choosing, I said no, use warehouse and you use database, use schema, you have to provide it, because the same hierarchy only you are storing all your data inside your database. So I can go with my demo now. I can go with the worksheet. Okay, so if you want, you can see all your historical worksheet here. If you want to rename it also, you can do it. I just kept as a demo Snowflake. And you can show that all the before that you have to choose this and all properly, because if I'm not using use warehouse, use database, use schema, you have to go and choose here what is the schema, what is the database you wanted, and what is the schema you wanted. Okay, so otherwise if I'm not using use command, okay, I can go with this. And then here you have to go which role you want to use it. Always prefer the system admin. Some privilege operations you have to go with that account admin. And here you can go and choose what the warehouse. except that by using this set command, we can go with directly this UI, and you can open it. And share command is a very important command, very important features in Snowflake. You can share your data to anyone in the world, or anyone those who are not having even Snowflake account also. That is also possible in Snowflake. And show warehouse, what it will show all the, you just click, and like how you are working in the SQL, the same way it will show you all the data warehouses in your particular account. I have only one test warehouse. It's always in suspended mode, because every time it will be in the suspended mode after if you are not consuming. So if you want to resume it, you have to use the alter command. Then it will be moved from the, oh sorry, okay, it's a test warehouse, because I used that as a previous one. It will be, it will be suspended now. No, sorry, it will be resumed now. If you want to check in the status, you can go and show the data warehouse. Initially it will be in the suspended mode. Now it's a started mode, right? So it's ready for working. And same way you can alter warehouse. If you want to suspend explicitly, you can suspend it. If you want to resume explicitly, you can do it. And alter command also you can do it. But why we have to use the alter command? By explicitly, if you want to scale up and down, you can do by this. And as I said already, auto suspend, auto resume, we can do what is the minimum cluster size, what is the maximum cluster size. We can do it by using the alter command in your warehouse. And scaling policy also we can change by standard and economy. So this is, if you are running, it will change automatically your test warehouse. So if you are changing this is into test warehouse, automatically it will change the setting of your warehouse. That's okay. If you go and check it in the data warehouse, you can see that property auto suspend this much, auto resume this much, and all. Okay, so and such a way you can create the database. Okay, they create database, this one. So if I'm opening that, it will throw the error. Why? Because I already have the same name. Okay, so if I want to change it, you can change by sys. I think sys also have. Yeah, sys also have. I can give system. So such a way you can create the database. Okay, so you can create the database. If you go and check in the show database, it will show all the databases available in the particular sysadmin. Okay, already I have created few. The Snowflake and Snowflake sample data, it's already existing in your Snowflake itself. Such a way you can create by using cloning also. For example, the same system I'm just using. Okay, I can copy in the clone. What it will do, it will clone the particular database, and it will create the new one. Will it take the physical space? No. So it will take the existing logical only. So whenever you want to change, I think, okay, I have to copy this properly. Demo. Okay, I can go and create clone also. It's possible. Okay, so the now if you go and check in the database, this will be added. Okay, this will be added, and it will show this is the cloned one. Okay, so such a way you can create the schema. I don't want to waste time. Schema, and you can drop the schema also. Once if you drop the schema, you can undrop also. It's possible. Okay, so if you want to see, now I dropped, okay, 3. I can show you if you want. I can drop this. If you go and check it in the show, it won't be there, because now only it's created, right? So that 3 will not be there, right? So if I want to create it again, because by mistake I done that. So I want to undrop. Okay, so database successfully restored. This is not we are having in your normal database. This is a feature. Okay, you can see this result also. So such a way you can do for all schemas and tables, and always use this for your every time while you are creating this a new worksheet. You just use this and do your operations. Is best way to um, uh, prepare your worksheet. This is a way you can create your table. Okay, create table name. While you are creating the table name, always, why I am using this in the double quotes, because if you are using the small case, uppercase and all, what as it is, we will get it, we want to get it, means you have to use it in the double quotes. Okay, so same like normal database, how you are creating the table, you have to create it. If you are showing show tables, it will show all the table which is created. I think now I don't have any data. Okay, I can create this. I think it will ask you the system properly. And data schema is not there now. Let me check once. Okay, schema is not there, so I have to create it. Okay, so create. While creating the schema also, I need to insert the database, and here I can give you system. Okay, the same name I have to use it. Okay, so the schema is created, and here also I can go and change the schema name while creating the table. Okay, so demo table. Okay, let me check if there is or not. Okay, so demo table is created. So now you can go and check in the show tables. It will show you. Okay, creator show table. Where is? Actually, it has to show all the table. Not sure. Okay, let it be. So if you go and describe the table, like what the table you have created, if you want to describe, you can go and use this. Okay, and it describe all the columns and everything is, it is a prime, we have the unique or those things and all, we can get it from this describe. And we can clone, and we can use the like command also, that you can practice in yourself, and you can check the retention in account, because in account how the data retention in days is there, and we want to change only for the particular table. If you want to change, you can do it. Okay, so if you are change that, okay, here I am changing. I'm not sure the demo table is there or not. Okay, demo table is not there. Okay, so if you have any table, so you can go and check the set data retention time in days, it's equal to 60. If you are changing, because it's default, it's 90. If you are changing it 60, then you can go and check it in the show parameter. Then it will show you all the whether it is updated. The data retention timers, instead of 90, it's 60, it's updated or not. You can check it in the show parameter. Okay, so now we can go with the demo for the stream and task. Okay, so here I am going to create one item stage. I think already I have created in sysadmin item stage. Okay, item stage is already created, and there is two table I am creating. One is stage. Okay, item stage, it's a staging table. The staging table, we have a 3 columns: ID, name, category. Okay, so this is what you are getting from the source. This is what you are getting from the source. And then I am creating another one table. It's an item table, which is derived from the which is derived from the, or which is derived from the staging table item. Okay, that's all. So what's the difference between stage and this target table? So additionally, I have 2 more column. One is insert date time and update date time. That is why I'm taking from the timestamp functions. I'm using the insert date and update date. So this will do by the task and stream. Okay, so this is the only table I am having. So here I am inserting the data, how it will fetch the data from this, and it will do 2 additional transformation on this table. We are going to see it. Okay, so first what you have to do, so after creating the table, you have to create the stream. Okay, stream on this item stage table, staging table, you have to create the stream. So you already, I already created. Okay, so creating the stage, okay, stream, and then if you are go and check it in the show stream, so it will show the streams, okay, when it is created and against which table it is created, everything it will show. Okay, okay, this is, and what table against what table it will which schema, and everything it will show. Okay, so next you are inserting them some data on it. So before that, let me see, some there is some data in the item stage. Where is item stage? So, okay, item stage. Okay, because yesterday I have okay, it's not showing some data. So okay, I'm inserting some data on it. Okay, okay, so it's a 3 rows updated, it will come. Okay, number of rows inserted, it's 1. Okay, it taking one at a time. Okay, so I can check this. Okay, so only one it's taken as account. I think only one by one I have to do it. Okay, it's already there. Okay, we can check this, select star from item stage. Okay, so we can create this stream. Okay, select star from. Okay, stream is updated. Okay, and show stream. Only one stream is created. Okay, I can did this operations, and I can check that what is in the select star from stream. Okay, here it is no data. Okay, I can do some update operation on it. I can see one update operations. Okay, I can check this, select star. Okay, so as I said earlier, I did the update operation, right? Because it's not showing the data in the stage table, but there is a table. I don't know why it is not showing the data for the select start from the stage table, but it is already there. That's why after I deleted, it's showing that after I update the operation, right? Because I just update, I did update operation, set name is equal to product is equal, set name is equal to product 4, where ID is equal to 3. So that what I have added. Okay, so now what you are getting, insert and delete. So is update operation is equal to true. Why? Because every update operation, so first it will do the delete and then it will be insert operation. So that we can check from the streams, and there is a unique row ID, you will get it. So this is how the stream will work. And after that, what you have to do, you have to create the task. So you can do a task by either stream or serverless, or like a user managed task. Serverless in the sense you have to use the user task manage initial warehouse is equal to small. Otherwise, you have to use your current warehouse. Warehouse is equal to test warehouse. The schedule will happen for every 1 minute. So when the task will start the process if the stream has the data. Okay, so it will check because now you have the data that you have checked in the stream, right? So now if you run this, actually no, we don't want to run every time. It 1 minute one, it's automatically it check that particular stream it has the data or not. If there is a data, it will start. Okay, initially let me see what is the task. Show task, we can see. Okay, so as I said na, so the task will be will be in the, okay, the task name is this ID, and it will be in the suspended mode. So yeah, so the state will be suspended mode. So what you have to do, first you have to resume that mode, so then only the task will be happen. Okay, so now you can go and check the task. It will be started. Okay, so if it is started, then automatically it do this task. And if you go and check it in your select star from item, this is nothing but your target table. You go and check, that will be inserted. Okay, now there is no result. I think I'm not able to see the select star from the particular table. I have the problem. Maybe you won't have the problem, because the same problem I faced in this staging table also, the same problem I'm facing in the item also. I'm not sure. Yesterday I have seen all those things, it's properly, but every time while demo something, it will be the problem. Actually, let me see in this demosis, not demosis, it's in the public, and the stream and task. I can check in the table. Okay, item table. Yeah, it is also not showing the data. That's why we are not able to get that. Maybe the compute, the node which I used is not working properly. That is why the problem, because this one we have created, right? That's why it's not providing the enough computing process. Even stage also, it's not that data. Okay, so that's all from my end, but you can try it in your level. So if you want, I will share you all the coding. So nothing, first you have to create the two tables. Okay, without inserting data, first you have to create two table. One is item stage and the item. So item stage is a staging table, and this is the destination table. So while you are creating the staging and destination, you just make some transformation. I'm not doing the transformation, just I'm adding two more columns. This is what properly you will do in the data warehouse. Okay, so when you have inserted, when you have updated, you have to add the column that we are calling as the housekeeping columns. You have to add it, and then you have to create your stream against that staging table. Okay, then you can check your stream, and after insert some data, you check your stream. Definitely there you will get the three columns, like update is action, and row id you will get it. According to that, you can find it whether it's a insert query, update query, or like a delete query. You can find it. After that, you can create your task. Okay, so either you can go with the serverless or your own based. Okay, so and at the end of this task, okay, so the task you have to schedule it properly, 1 minute once, or like it's always in the minute wise. Okay, so 1 minute or 1 hour, whatever it is, it should be in the minutes. If it is 1 hour, you have to make it the 60 minutes. That's all. And obviously you have to use the when condition. In the when condition, you can add anything also. Suppose you want to only insert query, then you can after has data, you can keep that metadata is update is equal to true, not update. If it is insert only means whatever the condition you want to keep it, you can keep, and you can do your normal SQL query behalf of your task. Okay, here I use the merge query. You can use the insert query. You can use the any kind of stored procedure also. You can use it in the task. So just think it before doing the task. You have to get the permission from the account admin. You can able to alter the task which is created in the sysadmin. You have to go and get the grant privilege from the account admin. Use the same thing along with the account admin permission, and then do the task. And then after that, after creating the task, it will be in the suspend mode. You have to resume it by using this query, and then you can run it, and you can see the target table, whatever it is done in your through the streaming process. Okay, the update, the cdc, you will get it in the item. Sorry, I can't able to show that. Definitely very very sorry, because yeah, I think now we got it. Maybe it takes time. Okay, so now we got it, right? So what we have updated, it is added in your item table. So I can do one more also. I can do some insert query on it now. So I can change this value is equal to 5 and product is equal to 5. Maybe the computing it's getting delayed. Okay, so category is also 5. I can make 1 for my satisfaction. I'm doing insert. Okay, yeah, 1 row is inserted and I can go and check it in my stream. Yes, the ID 5 is inserted, right? It is inserted. Okay, and I can wait for a minute because I want to check the task it is in starting mode or not. This is what you have to check every time. Yeah, it's starting mode, so it will start it and you can wait for 1 minute and then you can check this item and you will get that category 5 also. It's not it. Maybe it takes time because previously also it took time to compute it, right? Yeah, we should wait for it. Maybe. So meanwhile, if you have any doubt, you can ask.
Participants, you can unmute yourself and you can ask any doubts. So now you can ask your doubts with Theresal. I hope any doubts in the.
Yeah, it's added, right? So because
Yes.
it's taking little bit time for the computing, so no problem. You can do it in your own. So definitely you can do the CDC and the same ETL process in your own system also. Any doubt in the stream task? Please ask your questions.
So participants, you can unmute yourself and you can ask any questions related to Snowflake. So I hope there is no questions from the audience side. So hope Theresal, we can wind up the session.
Yeah, thank you so
Yeah.
much, Gavaskar, for giving me the opportunity to so deliver the Snowflake in your forum. Thank you so much. Yeah.
Yeah. Once again, on behalf of Multicloud for you, we like to thank Theresal for providing an end-to-end session on Snowflake. So I hope that audience, it will be very much useful for the audience and you can kickstart your journey on Snowflake. Once again, we like to thank all the audience and the participants. And the secret code for downloading the certificate will be shared to your respective mail ID. It will be done within 2 working days. That's all for the day. Thank you, audience.